Hello again for our first session today. It's our pleasure to present to you Stefan Schaper with his presentation on systemic innovation approaches in pharma and MedTech. So Stefan, he is the founder of Schaper Tech, an innovation and technology consulting firm. He studied biology at the University of Hanover and the National University of Costa Rica, and has worked over 20 years in companies like Fresenius, Roche, and Bayer in innovation and leadership positions. He led international projects in the fields of digitalization and R&D efficiency, and also he led initiatives for the improvement of processes, intellectual property generation, cost savings, and problem solvings. Currently, he used the theory of inventive problem solving, design thinking, sprint and agile methods for purposes such as idea generation, intellectual property generation, cost savings, and digital business model definitions. And as we all know, that digital business models are in the verge of in our today's industries. So we are definitely looking forward to hear his experience in pharma and MedTech. So Stefan, very much looking forward to your presentation.
Yeah, good morning. Thank you very much for the warm welcome. And it's also a pleasure to be here in this circle of pharmaceutical executives. So I'm going to speak a little bit about innovation methods, systematic approaches to innovation, and also maybe a little bit how I came to that. I'm now, as Mario just said, over 20 years in the industry, and like 10 of them in direct innovation management. And I was a little bit frustrated when I started this part of the job, because most of those classical innovation management approaches are purely administrative. So you manage a portfolio, you manage a stage gate process, and that was it. Yeah. And some years ago, I came into touch with some very exciting methods to foster more creative ideas to solve severe problems, like for patent generation, cost savings, when you just don't want to save 3 or 4% of something, but 20 or more percent. So really some disruptive things. And this was my touching point with TRIZ, the theory of inventive problem solving. And I'm going to introduce some of those approaches here. All right. So this is, just jumping a little bit. So this is my agenda. So I'm going to jump right into some very interesting topics. After the introduction, we are going to speak a little bit about IP generation, patent circumvention. There's one tool which is a little bit hard to understand, but very beneficial, which is called function analysis, and then maybe some nicer topics like technological trends and then at the end. All right, my slogan is make innovations fly, and I'm going to stress that a little bit. So I personally like to be in the air, and I think this also helps a little bit in the business of innovation management, because it really takes you to a different point of view. All right, so as I mentioned, I'm using TRIZ a lot. This is something which is already known in the engineering space. However, it is hardly used in the chemical or pharmaceutical space. So this is also kind of my niche where I'm moving. All right, first of all, maybe one question. When do real innovations happen? So we obviously have many of those things in mind. We are thinking about iPhones or maybe computer chips or things like that. But what is really behind that? And I came here to a number of 3 different things. One is a contradiction has been solved. So a contradiction is something when you need to increase, for example, the performance of a car, but this will cause then some disadvantages like energy consumption, noise, and so on. So this is a typical contradiction situation. But we also see contradictions a lot in the business. So we want to reduce costs, but still be compliant with all pharmaceutical laws, or we want to have a new substance, but still guarantee safety. So contradictions are everywhere, and real innovations happen if you're able to solve such a contradiction. Another principle is something is trimmed. So I already mentioned the first iPhone. So here the radical innovation was to trim something, so they didn't have a keyboard anymore. And something that was obvious for us for decades has been taken away. And we can also observe that in other areas as well. And last one is a different scientific effect or method is used. So remember vacuum cleaners, for instance, they have used filter bags for decades, and then somebody came up and used vacuum cleaners without any filter bags, just by using a special kind of vortex. So this is also a new approach to innovation. And we also see that in the pharmaceutical space. Just think about the mRNA technology, which is currently revolutionizing the vaccination. All right, so these are three different ones. The good thing is this kind of innovation can be generated in a systematic way. So it doesn't really take a big genius to develop that. It is not necessary to have Sarah New Steve Jobs or a big inventor. It can be done in a pretty systematic way, and this is really something very powerful. So as I've mentioned, TRIZ is an innovation method. It is a toolbox of 50 different methods, and depending what you need, it can be also kind of assembled to your specific situation. The inventor of TRIZ was an engineer who was helping others to develop patents, and so he had to read many patents, and he discovered that there are always similar solution patterns in many patents. So he made an amazing effort, and he condensed all those solution principles from them, and they are now available for free, so you all can use them. And as I mentioned, they are originally from the engineering space. However, they are totally branch independent. So I've used them a lot in the development of chemical reagents in pharma, diagnostics, medtech, and so on. So this is something which can be also applied to your field of business. And as Mario already said, it's also possible to apply that also for digital business models. So there are some variants of TRIZ who also deal with that. Okay, there are already quite a few companies applying TRIZ. Most of them are in the engineering space. Companies like Samsung or Hyundai are heavy users of TRIZ, but also some life cycle companies like Sanofi, for instance. I used it at Roche as well. There's a strong community at Siemens. And I'm also looking forward to speaking to you, maybe for possible expansions here. Okay, so why do we do that? Of course, if you have good experts in your field, you can do many things with brainstormings, no problem. I mean, most people in your research and development departments are skilled scientists, so for many things, they will still develop good ideas. However, in most situations, you will reach some limits, especially when the state of the art is already pretty high. You need to do something else. So this is like a football coach who tries to bring his team to Champions League. So you need to do something else if you want to reach the next category. And here in innovation, this is definitely using systematic approaches. All right, so maybe also question here, what do you think? What is the most important KPI in aviation? So the typical answers are yeah, enough fuel or speed or altitude or travel time or things like that. Yeah, so this is usually the answer I get. But if we take it down really to the essence, especially if you think about we want to stay in the air, we don't want to crash. So here, I think the clear answer is airspeed. So without speed, the plane can't really stay or hold itself in the air. It will stall and fall down. So it's not about travel time or fuel or whatever. It's really about speed. And the same applies for innovations. We need to be fast on the market. It's good to have good quality. It's good to be compliant, but this is something that everybody has to do. It's in our market, of course, we have to deliver good quality and a compliant product. However, speed is everything, and the first mover and the first to market company is the one who makes the profit. And I think the current vaccination situation is exactly a good example for that. So the companies who were first on the market, they are currently having most of the attention, they have most of the market, and the others are just yeah, filling the gaps. All right, so speed is very important, and to gain speed, I have here a couple of methods which really can help to accelerate R&D and innovation. All right, so let's speak about IP generation and patent circumvention. I'm jumping right into some complicated topics. I hope you excuse me. One situation I had like 5 years ago, some scientists came to me and said, we are working here on a field with a very high state of the art. Everybody says it's impossible to file new patents because it's really, it has been under really heavy research for more than 20 years. So can we still do something about it? And there's one method coming from TRIS, which is called the 76 standard solutions. It sounds a little bit strange, standard solutions, so there's something standardized just for my problem. Yeah, but really it's like a library which everybody can use with a couple of abstract solution proposals, and you can adapt that to your specific situation. So the first part is that you have to describe your problem as a conflict of two substances and a field. So two substances can be two molecules which are in conflict to each other. A field is any kind of yeah, physical interaction. So it can be some magnetic field, it can be a chemical interaction, and so on. So you describe your problem like that. So in that case, for example, I had a low yield in the production, or I had also one molecule which did not attack an analyte in a proper way. So here I could describe this problem as a conflict of two substances, or an insufficient mechanism of two substances. And then if you have that, you can go into that library and just search yourself. You get a number of abstract solutions. They look a little strange at the beginning, but if people are trained, you can develop ideas just really at high speed. And I remember we had one situation to develop a diagnostic reagent, and we were able here to develop with very low effort 3 different patents. For each patent, we have invested like 1 hour. And because the scientists were really short in time, we have invited them over a lunch. We've ordered a pizza, and during that pizza session, we have brainstormed using this method. So pretty effective approach. And at the end of those 3 lunches, we had 3 different patents. And one of them was even groundbreaking. So this is a very strong approach to generate high quality ideas in a very short period of time. Yeah, those are the references, so those are just examples of some patents. Others I can't tell because the patents are not yet out. All right, so this is one example for quick idea generation. Another one is like for digging deeper. In some cases, you need to understand your problem better. You need to get all the different relationships between molecules or your machinery and other things. And you might also want to apply a technique called trimming. So take something out in order to create, for example, higher state of the art, generate new patents, or also do radical cost trimming. So this is function analysis. I'm maybe telling a little bit the story how I had my first contact with function analysis, and this was during a TRIS training, I think, in 2013. And to be honest, I've been quite frustrated because during my 3 days TRIS training, like 1.5 days were just about function analysis, and it's really pretty tough, that part. So I'm just trying to give you really a condensed version with the essence of it. So what is function analysis doing? So basically you check your system, you list all the components of your system, and a function is anything which changes a parameter of something else. So what, for example, is the function of a helmet? So usually people would say a helmet is protecting my head, but this is not a very good function. So I'm not changing a parameter here. So the function of a helmet would be the helmet stops a stone, for example, or the helmet disperses energy. So this would be there a change of parameter. So this is a little bit weird as a language. However, it provides you a lot of insight into your technological system and also into your, can be also used for your customer situation if you want to determine hidden requirements. And if you have done that, you can evaluate all those functions. So you can rate them if they are sufficient or insufficient, if something is done in excess, or if there are, for example, harmful functions. So this can be useful for problem solving, for improvement tactics. It can be used for trimming, as mentioned before, and also for patent circumvention. Yeah, this is one example of a chemical product. So somebody wanted to circumvent this patent. And what you usually do, you talk to your patent attorney, you try to check if there is some mistake in the other patent, and sometimes also you speak to your scientist if they have an idea. But function analysis makes a patent very readable and transparent. You can make such drawings based on other patents, and then you can try to attack them. And if you want to attack it by trimming, you're trying to take one of the components out, and then you are able to file a new one because you have a higher state of the art. And this is something very elegant to generate something new in IP. So how's trimming going? There is a set of so-called trimming rules. We are not going to see them in all detail. However, I'm going to show them. And what you usually do, as they are a little bit generic, you brainstorm with your experts if there is a way with that approach. So for example, trimming rule A says, okay, you can take out one component if the object of the function is trimmed as well. So if you can trim component B, you can also trim component A. So with that kind of approach, you speak to your engineers or scientists, and you're trying to go through all the different trimming rules. And of course, some of those ideas can also come out without applying TRIS. However, this is like a checklist. You don't forget anything, and I'm very sure that in nearly any occasion, you will get some new ideas which were not there without that. Okay, trimming rule B is a so-called self-service. So you can trim component A if component B is performing the function itself. So yeah, think about the smartphone example. So it was possible to trim, for example, keyboard because the screen was able to perform the function itself. Or trimming rule C, so something else is taking over the function. So sometimes you have more complex systems, and you can trim out one component because another component in the system which is doing something similar is, for example, able to take that over. I've seen one example of a motorbike. Somebody wanted to trim the tank of a motorbike, and they were able to modify the frame of that motorbike so that it was able to carry the gasoline. So also could be a way to interpret rule C. Okay, so this is for products. There is a number of 4 different trimming rules, and there is also a bunch of trimming rules for processes. So if you need to adopt your pharmaceutical or medtech processes, there's a bunch of 19 different trimming rules just for processes, so also very powerful. Okay, so something maybe a little bit nicer to speak about is technological trends. So there's also a number of different tools available in TRIZ to elaborate on trends. One tool I commonly use, like to get people into innovation mode, is the so-called system operator. So there's some kind of assisted brainstorming when I want to speak about the next generation of a product, for example. So what I typically do is, okay, I ask people to say, okay, what is the system you're currently thinking about? So this could be, for example, just to give a stupid example, a laptop. Then you're going to check what is the super system. Super system means the environment where this system is operating. And what are performance determining components? So this could be, for example, the processor. Then you go back into the past. You look for a really relevant period of time. So you go, for example, back 30 years. You'll also look how the super system looked at that time, and the subsystem, obviously. And then you're going to elaborate how the future could look like. How could the future of laptops look in 30 years? So you're going to start with the super system. You're going to look how the subsystem could look like, I don't know, quantum processors, satellite internet, and so on. And how could a system look like as a consequence of that? So I think a very interesting method, especially if you have people who are a little bit shy at the beginning, like and to get them into innovation mode. This is pretty useful. Okay, there are also some examples from clinical environments. So this was also done here with some experts some time ago. So here it was about mobile devices in the clinical environment. So here, like ultrasound scanners, data here provided by healthcare records. The environment was already a little bit digital, but not so much. And here in the past, it was pretty analog, big devices in the environment itself. No Wi-Fi, paper records, and so on. And then we brainstormed how the future could look like, and we had quite a lot of ideas here. Also, in TRIZ, there is one tool called the Trends of Technology Evolution. So this is a set of 11 different trends which apply to all technological systems. So when the guy invented TRIZ, he not just condensed some solution principles, he also discovered that systems evolve over time, and that there are some typical developments regardless if you have a clinical analyzer, a car, an aeroplane, or a pharmaceutical substance. And one of those 11 trends is the trend of flow enhancement. I've mentioned before that TRIZ is also good in optimizing processes. So this is a very strong trend, like for the development of good process environments. So it has a number of sub-trends. So you can improve, for example, the conductivity of a flow. You can improve the flow itself. You can reduce negative impact factors. So there's quite a number of different things, and there are 40 different approaches how to improve a process, a technical process. So very, very powerful. Okay, so here are just some examples. So for example, one part could be that you allow one flow to carry another flow, or use a super system channel. So for example, resources that already exist to speed up something. So those are just two small approaches, and yeah, something which can be also adopted to your specific situation. They sound a little bit generic, but if you take that as a trigger to your experts, then they might be inspired and develop some new ideas specifically for the problem that they need to solve. All right, so I think quite a lot of options, quite a lot of opportunities, how to apply that. What I typically do is I organize workshops with your scientists, or if you say, okay, this is so interesting, I want to learn that myself, then you also can, of course, have a training interest. As I mentioned, those libraries, they are free, they are public domain, you can Google them. However, a good training or instruction on them makes sense, because some of them are a little bit abstract and need to be adopted to your situation. What I always do when I organize a workshop in a pharmaceutical environment, I try to define a problem statement before that. For me, there's nothing worse than going into a workshop without a clear target and a clear problem statement, because it usually leads to endless discussions what the problem could be. And based on that problem statement, I select the appropriate methods. As I mentioned, there are 50 different methods and twists, and so of course it's not possible to use all of them, but you need a handful of them which are appropriate. Okay, then typically we present the problem statement, discuss it, check if it's well understood. Then we do some kind of creative warm-up, for example, using the system operator or the trends. And then we do deep ideation, for example, using function analysis or other tools. Yeah. Also for me, it's a no-go to have no next steps after a workshop. So there must be a clear outcome and some follow-up, otherwise the time is wasted. So this is, of course, very important for closing it. And as I mentioned, there are really time-saving formats. In some cases, just over lunch, we have generated new patent ideas. So this is pretty effective. However, it needs some preparation, of course. All right, so in case you want to learn that, I usually do it in small groups with lots of examples which are fitted to your industry. I mean, we are now in pandemic times, so also, let's say, at least during summer or spring, it's also possible to do those trainings outside, or online, or via virtual reality. So some of you also might have experienced this kind of glasses. So it's also possible to do now trainings under virtual reality conditions. All right. So as I said, it's refocused, always with a problem statement, and it's saving your time. Okay, so for me, TRIS means focused. It's really something time-saving, which can accelerate time to market, time for development, and for me, this is extraordinarily strong. All right, I think a good word for closing. So we can't expect to solve our problems with the same thinking we used when we created them. So, I mean, if we want to change something in pharma and speed up things and be more innovative, then of course we have to change the approach a little bit. So thank you very much for your attention. Feel free to connect. I'm going to be a little, some more time online here, also in the networking area. I'm happy to connect with you also via LinkedIn or Xing. So feel free to contact me. Thank you and bye-bye.
thank you very much, Stefan, for the nice, interesting insights. So we enjoyed all of that, as we're all working in an environment where intellectual property and where innovation is a key for success. So one question that we wanted to ask you, so you were speaking also a lot about workshops. So how do you see the future? So as we are now, we received a question from the audience, so that now being most of us in home office, how do you see this missing opportunity of process workshops and really getting out all from our innovative thinking power out of the people when they normally gather together? So in online workshops now, it's a little bit more difficult to do that. What do you think?
Absolutely, yeah. It's of course the best workshops are taking place when you're closed somewhere in a room, somewhere a little bit outside the factory or outside the normal facilities, and you meet people, and you're also able to have some side discussions and so on. So of course it's possible to do workshops with VR or with Zoom or all those other means. However, yeah, it's not totally the same. Yeah, so there is some limitation. However, this should not keep us from doing them. I think the worst thing that we could do is just stay in our home office and don't do workshops anymore, because this will not push innovation forward. So yes, there are some constraints, of course. However, we should not stop being innovative.
Yes, I think this is a good closing word. So thank you, Stefan, for that. And as you said, so we would welcome you to also answer questions, of course, in the chat or in the networking session. So really enjoyed your insights on the topic, and we'll be looking forward to connect later on and give some further questions, and of course invite all the audience also to give all the questions to you.
Okay, yeah, thank you.
Thank you, Stefan. And we will be just back in 5 minutes with the next sessions of the latest trends in generics. So thank you again and see you soon.
Bye-bye.
Bye.